All right. What I'm going to try to do tonight, Captain Eddie asked me to not to turn so much, and I didn't. This is a pretty lengthy thing. If I had actually turned and did all this as a real demo, so I have broken it up and videoed it and broken it up, and just trying to show you the process of doing a segmented piece. This is, you remember the segmented spline piece that I did? That's what the demo is about. It's trying to show you how I did this, the steps involved. So let me show you one other part. The last time I showed that, I talked a lot about the spreadsheet, and I don't want to turn anybody off to segmented turning just because they don't have a spreadsheet or they don't want to, don't know how to use one. Because you don't need the spreadsheet. All you really need is a graph. Like I have a graph here of deal. I usually go out to either YouTube or Pinterest or maybe even Etsy and find ideas. And then I take those ideas, I actually make a screenshot or I print it, and then I reverse engineer it. I figure out how many rings are in it, how many segments I think they put in it, that type thing. And then I can draw it out on a graph. So I print out a graph like this. They're 1/4-inch squares, and use that to kind of draw out the shape that I want, the shape of the vessel. And then I actually take that and add blocks to it. Now the blocks are just to get the line, to make sure that you can get inside that line. Let me see if I can get a little closer here. But you see how I've drawn the shape out here. Then you make your blocks. Each ring, each step of this is a ring, and you make your blocks to where they can, where the side of this thing will actually fit inside. Let me see if I can figure this out right here. So as long as you can fit this inside that block, the side of the vessel. The vessel here was probably going to be about 3/8 of an inch thick. And all I'm trying to do is to get a block, this block right here, to make it long enough or wide enough that I can make that swing. When I go to cut these, I want to make that swing through that block. And that's all I'm really doing. I don't have to do anything on the spreadsheet. I don't have to put this there. I do it just because I want to put other figures and I can actually write it down, in the spreadsheet. But you could all do this on a piece of paper. You don't have to do the spreadsheet thing at all. Let me go with one more step here and show you the formula. That one out of the way. Let's see which way is up here. Nope, wrong way. No.
Nope, you had it right.
I had it right. Okay, it was backwards. That's why I couldn't see it. Okay, but here is the formula, and I've actually sent that to David, and see if we can't. Here we go. See if we can't get it on there. But the formula is not hard. All you're doing is taking the radius. I like to work in radius because then you're at the half of a circle, because that's the way I'm going to draw it out on the piece of paper. I just want to draw one side. I don't have to draw the whole vase, both sides of that vase, just one side of it. So I'm working in radiuses, and you take the radius and you multiply it times 2 to get the diameter of your vessel, and then you multiply each. And this is each seg or each ring. So you'd take a ring. Let's say that ring is 6 inches in diameter, or 6 inches in radius, and you're going to be a 12-inch vessel. And then you would take that and multiply it by 2 to get the 12, and multiply that ring times 3.14 to get the circumference, the distance all the way around that vessel on that ring. And then you divide that by the number of segments that you have. So let's say we did 18. I think in the example here, I was using 18 segments. So you divide it by the 18, and then I have a fudge factor that that I multiply it by just to give it a little extra room. And I'll show you that in a second. But let's go on down this formula thing. once you get that formula, you use that same formula for every ring. So, if the ring gets smaller, of course, the length of your segments are going to change. And same thing about, as far as the angle, the angle is nothing special. It's, what is it, 360 degrees, and you divide it by the number of segments, and then you divide that again by 2 to get the angle. So each segment is going to be cut at a certain angle on each side.
So talk to me about the fudge factor.
Okay, let me show you the fudge factor here. I've got another one here. I thought that would come up. You have the your block, your segment that you've cut out, and you've got the angle on each side, and it's flat across the top. But when you put that in a circle and you're cutting out a circle, well, you're going to cut a little bit, the top edges off, trying to make it, to get it to the flat part of your segment, to get it to this level. When you make that circle through here, you're actually cutting it off. So it's got to be a little bit longer on each side. This top segment, this top length up here, has to be a little longer on each side, just so you can compensate for the circle that you're going to actually cut. Anyway, but that's what the fudge factor is for. If your segments are little, let's say you do a 48 segments per ring, then the fudge factor doesn't matter much. I mean, at that point, it's so small, this distance across, this length across the top of this segment is so small, you're not going to really see, you're not going to need the fudge factor. And when you get down, I don't like to do a lot of 12 segment things, but I have. And if you do 12s, then you definitely need it, a fudge factor. And I usually just keep that fudge factor in here every time. It just ensures that my final ring is going to be the size that I wanted. Let's say that I wanted it to be a 12-inch in diameter vessel. Then if I leave that fudge factor, then that ensures that it's going to have enough meat there to accomplish that.
Very interesting. Thanks, Bob.
Okay, so that's the meat of it, I guess. But let me go ahead and do a share screen here, and I can show you the spreadsheet one more time. So let me do that. Double click it maybe. Yeah, how about that? Can you all see that?
We got you now. Yes, sir.
Okay. All right. This is, I've got it in the spreadsheet. I've actually drawn it out, and I know where it's going to hit through here. If I draw it out on here again, and I can draw that vessel out, well, I can actually, see the outline of it through here. And the only thing I'm doing here is so I can write it down. I have someplace to put it. But it doesn't, you don't have to have the spreadsheet. It's not doing anything for me for the calculations other than me to sit there and add it up. Let's say that I wanted this ring is 1.5 inches thick this way, and it's 0.75, the top of it. When I use my formula to figure out the length of that segment, it's going to be 0.75. And if I take the 0.75 and multiply it times 18, then I get my 13.5 inches. That's how much material I have to have for that ring. I have to have 13.5 inches of the material to actually make this ring. So I can go through here and add up and decide how many total feet I really need of each size ring, like 1.5 inches material, how much material I need of it. If it's only this 3/4 inch, how much material do I need for that ring and this ring? And then I add them all up. But that's just me, how I figure it out. You don't have to, you don't have to have a spreadsheet. All this can just be done on a piece of paper. The formulas, let me go over here to the formula. And again, I did this, and here's the formula up here. So if you went down to E4, which happened to be sitting on, it's a 1 inch radius. So it would be 1 inch times 2 would give you the diameter, times 3.14 would give you the total distance of the circumference around that diameter. And you divide it by the number of segments, which in this case is 18. And then you multiply that times my fudge factor. And this right here is how the length of that segment, that top portion of that segment, needs to be 0.375 inches to make a 1 inch radius ring. Of course, I'm not going to get down to 1 inch. I don't even know why I have them on here, but you know, a 3 inch would probably be, you know, more realistic. If you have a 3 inch diameter or a 6 inch, that would be a 6 inch diameter ring. So anyway, those are more realistic figures. But I just have it where I written down here, and you know, you don't. Again, you could have done this on a sheet of paper and just added them up, you know, just multiplied them all out and wrote it down. So you'd know what a 3 inch or a 2.5 inch or a 2 1/4, you know, size segment would be. And the same thing about the segments, you know, the segments are the same thing. It's 360 divided by the number of segments divided by 2, which would give you the cut angle on each one. 18 segments, if it was a closed segment, a solid ring, that's a closed segment ring, it's a solid ring, then each one of those angles on each side of those segments need to be at 10 degrees, cut at 10 degrees. In the open segments, you're taking the same figures that you had before and you're just multiplying it by some fudge factor. And I'm multiplying it here by 0.7 because I want it to be 70%. This is for an open segment. So in other words, the segments don't touch each other. It's like the vessel the guy showed earlier tonight. That's called an open segment because you can see the holes through it. None of the segments actually touch in the ring. And when you do that, you multiply it by some fudge factor. And here I've got a 70%. I want it to be 70% of a closed segment ring. If I want it to be more, I mean, less than that, then you know, you multiply it times 0.6 or 0.66. The problem with getting it smaller than the 0.7 or 0.65 or 0.66 is that there's very little meat there to connect one layer to the other. You can't go to 50% because you would have nothing there to touch. Anyway, that's the idea. And the angle's the same way. If you're going to make if it's 70% up here, if it's a 0.7 or 70% of that original segment, you do the same thing on the angle. So an 18 segment, if it was a closed ring, it would be 10 degrees on each side. If it's a 70, it's going to be 7 degrees. It's just 70% of the 10 is all it amounts to. That makes sense, guys. Okay, well, let me go ahead and start the video or go to the video, and maybe it'll make a little more sense to you. This is the actual vessel that I found on probably on Pinterest, and I printed it, saved it, and printed it. And then I go ahead. What?
We're not looking at it. We're looking at the spreadsheet.
Still at the spreadsheet. How do I not do that?
Well, do you have the image on your open on your computer?
Yeah, I do.
Well, close this one and you'll be able to share screen clicking on the image.
Okay, let me close this one. Is that what you're saying?
Yes, sir. And then go to share screen.
Oh, share screen again. I got you. You have to change every time, I guess. Okay.
Yes, sir. If you change the input, yes.
Okay, let's try that. Okay, now you see it?
Now we got it.
Okay, all right. So the image that I'm showing here on the left is what I actually saw on Pinterest, and I printed it, saved the picture and printed it. And then I dissected it. I went back and reversed engineered it and said, okay, well, this thing is so many layers, so many rings, and about how wide it was, about how tall I thought it was. And from that, I can come up and do the thing on the right, which I'm taking my, 1/4 inch graph and drawing the lines out here and figuring out what this vessel is going to look like. And then each layer, how wide this portion has to be to get that thing cut, to get it to cut in through there, And every layer depends on, if it's not a cylinder going straight up and down, every layer could be a different width, if you will, this way. It depends on how much of a swing you have coming through here. Like these are only, what, 3/4 of an inch, because I can turn that 3/8 of an inch up through there without a problem in 3 3/4 of an inch stock. Where these others have to be real long, pretty wide to actually get this thing to go through here, and cut it through there.
Bob, let me ask here, if you do this right now, all your blocks or your segments are the same thickness. If you vary thickness, if you put that on a spreadsheet in a different thickness, you can do the same thing you have here, correct?
That's correct. Yes. If you want to make it, what I show in this one is 3/4 of an inch. And I could have been, I could have made this segment right here, this ring, only 1/4 of an inch thick. And I could have made, made this smaller, and it would have shown that this would have been only 1/4 of an inch thick here instead of 3/4. So yes, you can draw it out and make it exactly what you want it to see. Just because I made mine 3/4 in this graph or in this particular one, my stock was probably closer to 7/8. I mean, not 7/8. Yeah, closer to 7/8. It was larger than 3/4, but I don't care. I'm still going to get basically the shape that I want, and it could be just a little taller than what I show here. Instead of it being 13 inches, it would have ended up being maybe 14 by the time you've added all the layers. But yes, you could make these layers 1/4 inch, 3/4 of an inch, whatever you want, and you could show that on the graph so you could actually see it.
So you're only limited by your imagination.
That's correct. That's correct. And and even this, I mean, you don't have to follow the shape you see out here. I just did. I liked this shape, and I thought it set off the splines real well. I could have made a different vessel out of it. I could have made a vase, standing up straight here or straighter. You just design it and you decide how you want it to look. That's all it is. So let me go to the video. So I have to close this out.
Yes, sir.
And you said go to the video here. Where is it?
Share screen, select the video. Now, is there going to be audio on the video, or are you going to talk through it?
No, there's audio on the video.
When you click when you select the video in the lower left-hand corner, there's going to be something there about audio. Click on that. Activate it.
Okay, let's see here. On mine, on the left-hand corner.
Okay, so by this point, I have decided what I'm going to make. I'm going to make.
But we don't sit there.
With spline.
Do you see it now, Eddie?
Open segmented.
Yes, sir. We're in the video.
Can you hear it?
I have laid it out on a piece of paper.
Yes, I can.
Mark this off in 1/4 inch grids.
Okay.
Draw out the line that I want, the shape that I want. And then I put it on an Excel program so I can kind of move it around and shade the blocks. You have to figure out how wide each one of these blocks has to be. So this one right here has to be 1 inch wide in order to get that curve in it. This one up here has to be wider. It looks like that is probably 1 1.25 inches to get it in this one. This one up here is 1.5 inches to get it in that one. But you figure out what width of blocks that you're going to want or that you need to get your curve in it. And you finally cut this thing out.
let me say one thing here. When you're gluing this up, and I actually start out gluing it in rings. So you put on one ring, you put on another ring, you put on a third ring, and then you start and you stop, and you start to come back, and you can't cut this ring, this third ring, because there's no support between the segments. But you can on these others. You start trimming this off, and you can see that I can actually turn this thing down to where those notches hit. So I cut everything off until that notch goes away. Same way down here. So you can kind of know where this thing is going to go just looking at your piece of paper. So when you start turning the inside, you're going to turn the inside first. So you start turning the inside and you're knocking all this portion away, cutting it all out of here. And you know to stop when you get down to these points. Let me go ahead and then.
I'll show you, I showed you all this before, but this over here is what I have come up with to say what size each row is going to be. This one right here is going to be 1 inch wide. And when I look up at the table and it says, okay, it's 7 inches, I mean, not 7, it's 6 inches. What is that? Yep, 6 inches in radius. Then this is the size of the top layer. The top, the longest portion of my block is going to be 1.501. Anyway, that's what I do. Then I come out here and go ahead and cut all the pieces. Make me a cut list. Here is a cut list. So I need 3/4, need 29 inches of 3/4, and then I missed it, so I got to add 54 more inches. Here is 1 inch wide and 27 inches and on down. So this is the cut list. So then I cut out all the pieces to the width that I want, to the height that I want and the width that I want. And then I start cutting them up in the right angle. So let me show you how to do that real quick. Okay, so you got all your stock cut out. You can get however many pieces you need. Like I need 18 per ring. So I've got the stock cut out like this 3/4. I know that I need this much stock to make so many rings out of a 3/4 inch piece. And before you cut them, you want to mark them. You want to mark the side that you're going to cut here. So just draw a line across it so you know which one was on top all the time. It doesn't matter a whole lot if your table saw is exactly right, your blade's exactly right. But if there's any chance of it being off, that's what that mark is for. So then you, after you get them cut and you're going to glue up rings, this is especially important if you're going to glue up whole rings.
Share screen again, Bob.
Alternate a top, a bottom, a top, a bottom, a top.
Let's see what happened here. We dropped that out.
I had it in good shape, Bob.
Yeah, Bob, that was in good shape. No
Yeah,
problem.
you were doing right.
Oh, okay. I thought y'all wanted me to stop it here. Let me go back.
Other than me.
If you're having a low bandwidth, all you members, if you have a low bandwidth, you get some skipping.
Okay, so by this point, I have decided what a whole lot. If your table saw is exactly right, your blade's exactly right. But if there's
Everybody
any
back
chance
in here
of being
again?
off, that's what that mark is.
We don't see the video.
Just got the volume.
All
Cut.
right, hang on here. Let me go back and I guess I have to share the screen. Huh?
There we go.
Yeah,
Yeah,
you
that
see.
looks good. Perfect.
Okay. Here we
And
go.
you're going to glue up rings. This is especially important if you're going to glue up whole rings. You want to alternate a top, a bottom, a top, a bottom, a top, a bottom. So if there's any discrepancy in that angle of the blade, these two will offset each other. And you end up with a flat surface still with no gaps down here between them. All right, what I use to, there's several ways to do this. You got your wedgie boards and all that stuff, and and I've tried them. I've made several different ones, but this one I keep coming back to. I kind of like it real well. Sometimes I kind of get nervous and want to drag the piece back, and I guess some form of a wedgie board is what I use to do that. But this is what I use to set up the miter gauge on this setup. The miter set, you can set it up to 1 degree angles anywhere on your miter gauge. So this time I set it up to 10 degrees. Let me show you that one. Angle that you want from 0 to 10 degrees. And for 18 segments, I need 10 degrees to go across there. And you set your miter gauge to that, tighten it down, and then there's my 10 degrees. Okay, so I still have my 10 degrees, and I have made this sled, if you will. I go across here, it slides back and forth with my miter gauge, and it has sandpaper on this side so the wood won't slip on me. And my blade, I always slide this thing through. You can see over here where it can slide through this slot and move it further out this way as I cut off things. But, you know, every time I want that blade to be right here. So I know where it is. I can put the piece of wood up in here, and I know that if it's on this edge, then that's where that side of the blade is. Okay. Does that make any sense? So let me, this is 3/4 of an inch thick. So let me show you the other half of this. It sits on the miter gauge, on the table saw slot. It's a 0 clearance in it that I've kind of wore out, but it is supposed to be a 0 clearance. So now I'm back to my table saw. And I've got my miter gauge up here, and you can see that it cuts right beside the blade. The blade slides right in here. So I put it up here and then actually cut it through so it would be flush every time. This over here is a stop gauge, or a stop block, if you will. I've got it clamped down. I've got a T-nut in here, and I can loosen this bolt up and turn it and make it the right length of cut that I want. I do have a screw on this side just to tighten it up a little bit. It was a little bit loose in the threads, and that allows me to tighten it a little bit. Yeah, the table saw, I don't know what you call these, insert, I guess. Anyway, has a piece that's at a 45-degree angle. That's so when you cut it off, if I'm not holding it, these small ones I usually hold because they'll fly everywhere. But a larger piece, I can cut it off and it'll slide down and away from the blade, so it doesn't get in the way of the blade. You back up here a little bit, and maybe you can see it a little better. But that's it. That's how I cut them most of the time. Like I said, I do have other sleds and other ways to do this, but I even went to the expense of making a fancy stop gauge that had a digital readout on it, and it's not worth it, guys. Don't even go there. I just thought I'd show it to you. Here's my digital stop block. It actually rides in the miter slot, so it can't twist and turn. And there's a bolt on here on each side, so I can tighten it and make it snugger fit, so it's not going to move, and I can lock it down in that miter slot. The front end of it has a bolt in it that's been ground down. It actually slides in a miter slot here, or a T slot. That's the miter one there. That's just a dado. And it slides back and forth, and you can adjust it and zero it out, and all you want to do there. But I'm telling you, I made it. I used it twice and said, yep, that's not what I want to do. So it just sits. Okay, so the first cut is I extend it past my edge here a little bit, just so I can go in and take that out and make it at the right angle. So I want the first cut to be at the correct angle, my 10-degree angle. So let me do that real quick. And okay, as you can see, it went right down the side of it and cut it off flush with that piece of wood, or with my platform that I have here. Then you turn it over. You bring it up to your stop block and make sure it is the right length, which it is. And I've already cut it once. So I need to make 18 of them. So you go right beside that stop block and cut it off at the right angle. Let me do that for you. Okay. So there it is cut off. It kicked it to the side like it should be. And there is my 10 degrees on each side, and I got to make 18. Okay, I wanted to show you this too. I do have a hold down, if you will. If my piece gets too short here where I can't really hold it safely without thinking I'm going to get cut, I did make an extension where I can kind of clamp it down. It's nothing special, and I've cut it up a couple of times, as you can see, getting it too close, but it does work well. It fits up against the back of this board and has a deal here for my finger, so I can stick my finger in it, so to keep it from sliding, and just put pressure on it, and it hold it right down, and you can take it right through there. So anyway, I just wanted to show you all that. So now that I got the pieces cut, it has little fuzzies. You see those little fuzzies sticking out? Well, you need to sand those off, and the quickest way, well, probably about the quickest way for me, just to drag it across a piece of sandpaper, and it'll knock them right off. And you do that to each piece, kind of clean it up to where it's no longer anything that's going to get in the way of gluing this thing up. Okay, so now I've got them glued up. I've tried the band clamps, the metal ones. I don't like those. They always tear out on me, and I can only use them once, maybe twice before I have to throw them away and get another one. So I've tried the tube method, and I do like that. I use that quite a bit. So you end up with two halves of a circle. You glue the two segments together at a time, so that you can, and then you can make them forward, the group of 4 and then a group of 6, and whatever it takes to get it in a half circle. And once it's at a half circle, you let them set, and you let them set in between so there's time for the glue to dry. And once you get the half circle, then you can come back and sand any indiscrepancies off at that half circle line, and that works well too. But if you're going to glue up a whole ring, and which is what I'm going to do here, I'm just going to put glue on all of them and glue it up. But this is called a string clamp. It came from Earl's Small Segment Shop on YouTube, and man, it works great. At first, he had you tying a knot over here, just like a bow tie knot on this side, and you stick a screwdriver through it, like I have here, and that's what you turn. You turn that, and you twist this line up, and it gets tighter and tighter around whatever. The strings do get a little glue on them at times, but that's okay. You have a hole going through here for the string. You have a slot on both ends. This one is the one that holds your screwdriver or just a piece of metal. It could be anything, a pencil, anything that's not going to break on you, and because that's what you're going to use to twist with. The other end has the same type slot, but then it has a little notch in it here. And that little notch is what you want to line up with a line on your blocks that you have that you're going to glue together. So this should be in the center of those strings, so that when you're tightening down, your pressure is right here on this corner to make it round. This works real well. This he added later, and I kind of like this. It's easier for me than the little knot, but it just slips through this thing slips through right here in the center. You pull it back to tighten it up, and then you pull them all the way up, and that's what holds it right there. There's no knot, no anything. So it's being held right here. So I slipped it all up, pulled these to tighten it up, and then I twisted it. So I twisted this up, so right in here is all twisted up, and now it's perfectly around this thing. And if you can see, it's almost a perfect fit. I can't get it a whole lot better than that. I can take that and sand a couple of pieces. It looks like it might be out of focus. There we go. Yeah, I could sand a couple of pieces and get it a little better, but basically it is pretty straight. When you get that all glued up, nobody's going to see that glue line anyway. So that's going to work great. Anyway, that's how I glue them up. So let me go ahead and glue the rest of these up. And okay, I've cut up all the rings and I put them in separate bags, little baggies, and mark on them what ring they are and how wide they are, just so I can keep track of them. But they're all cut up, and they already have the slots cut in there for the spines. Let me show you how I cut the slots for the spines. All right, so you remember the alignment line that I drew on the whole stick before I cut it up? I'm going to use that again here. On the closed rings, I alternated the line from the top to the bottom every time just to get this angle correct, just in case it was off a little bit, to get those angles right. But here I'm going to use it to make sure that I am the right distance. Every time I cut a spline, if I'm not truly in the center, it would make it off a little bit. So I'm trying to make both cuts on both sides with this alignment line facing out. So they're always on the same plane or the same surface when I cut them. So let me cut one and show you how to do that. This little board up here is just to keep it, little feather board just to keep it pushed up. Trying to keep them all in there tight. I do have a little device here that I can push them through with. So let me try this. Slot for the spline cut in here. Cut the little fuzzies off. Looks like my blade's kind of dull, but anyway, that's it. Okay, to make perfect splines the perfect width of your saw blade. The easiest way I've seen so far is to use two pieces of wood, sacrificial pieces, because you're probably only going to use them once, only for the splines. But you first run this one through here and make it width of whatever this is, 2 inches or something. You need enough here to be able to still push it through safely, the width of this, so you don't get in the saw blade. And then the other piece, you come back and you do the same thing, except for when you do this one, you don't go all the way through. You stop down here, so you have a little catch on this end, a little bit still sticking out, and we're going to use that to push the other board through, and then you'll have the perfect width of the spline. So let me show you here. just have a little thing down here that's actually going to catch my other piece of wood and stop it right here. I think I'm going to cut this a little bit, notch it to where it's a little straighter across here instead of just a little. So now I've done that. I've got that little piece cut off, and I do have a definite little notch there. So you put that up against your fence. And then you have the perfect spline. So anyway, but that's easy way to do splines, and it works out great. Okay, so now I have rings all glued up. This is my last ring. I glue them up like this, and then I weight them down, put a board on them, put a weight on it, and let it dry. There's the rest of them. I'm just now ready to run them through a drum sander and get them flat, at least one side flat. And then I'll be able to take them over and start putting them together and gluing them together and turning it out. Okay, so I've got all the rings glued up. Now I need to sand them to make sure at least one side's smooth. But the other side we're going to sand again once we start putting this thing together. But for right now, I just need to sand these things a little bit. So let me get started. Let me kind of show you this. You can see the drum. That's out of a piece of 4-inch PVC. It has wooden plugs on the end and some mounting hardware to mount it in the lathe or in the chop smith. And works real well. The dust collector works well. Didn't get very little dust out of it. Okay, that's it. I just need to go ahead and sand down the rest of these, and we'll be ready to put it together. Okay, so I've got everything glued up, all the rings glued up, and here I have a glue block on here, and tied to my 1-inch spindle, and I have glued the base of the vase on here, and I use this to center it. Longsworth chuck. To me, that's the easiest way. Okay, for those that haven't seen this, this is my way that I adapt this and make this thing a better machine. The shaft coming out of the shop smith is only 5/8 of an inch shaft. I've bent it twice, and the second time I said I'm not going to buy another one. So I straightened it out with a hammer, and then I made this adapter. So it goes from 5/8 to 1-inch by 8 threads over here, and with I think they call it a pillow bearing or something like that. But But anyway, it's like a 3-point hookup. I'm never gonna bend that again. And I have an 1/8 inch thread, 1-inch threads for 1-inch nuts or any adapter you want to put on. So let me face this off and get that started. Okay, I think that's good enough to sand. Let me go ahead and sand that. The sanding board is nothing but a board with sandpaper on it. And you just hold it up here. And what I'm looking for is this edge to be smooth and flat, not the rest of it. Okay, thinking to glue the first ring on here. And you don't need to put glue over that whole ring. So I'm just going to kind of mark it so I know where the glue line is going to be. And now all I want to do is put glue on this portion of it and glue it down. That's it. Okay, so I need to sand this side before I put it back, put the other next layer on. Okay, you don't want glue all over everything. So I marked it. So I only glue the bottom portion. I'm only going to glue this edge, not necessarily the center. So that's what you try to get the glue on. And just push it together. And kind of wiggle it about back and forth a little bit. Put some pressure on it. And what you're trying to do is to get them centered up here. A little bit off, maybe. Oh, that right there looks pretty good. Ooh, maybe. Anyway, that looks pretty good right there. And you let that set a few minutes. It only has to set like 5 seconds. And then you can put the next one on. But I'm going to give it a little longer than that. So that was 11, 10. I got 9 coming up. Okay, while we're waiting for this third ring to set up and for all of them to kind of dry about 15 minutes before I turn it, let me explain what I've got going on here. The other one you saw had a little short tailstock extension in here, and that was so I could get the banjo and the tool rest on the left-hand side of the headstock side of the live center. And here I don't want to do that. Here I want all of this apparatus to actually be to the right or to the tailstock side of my live center, so that I can actually turn large bowls. See, I've got probably a 15-inch or nearly a 16-inch platter in here. for the Longsworth chuck. But if I was going to turn a large bowl, which I am, this is going to be 12 inches in diameter, and I can't get 12 inches with all of this under it. So I move it on this side of it, and then I have plenty of room to come back and move this on the other side and turn whatever I have. So anyway, that works out well for me too. Okay, I have got 3 rings glued on to the base and ready to turn the inside and part of the outside, kind of rough it out a little bit. But otherwise, they're on here ready to turn. You can only turn the first 2 rings. The third one out here on the outside, if you hit it, you're liable to knock them off because it is open segment. But otherwise, they're ready to go. I've got 6 rings glued up now and partially turned on the outside, just kind of get the rough edges off and to make a flat surface because I want to use a steady rest to put around this thing as it gets longer. But right now I have gone ahead and turned out the inside. I've lost the video that I had turning it. But there is the inside basically turned out. I do have some more I can turn out of here. But this last ring, I shouldn't have put it on. I should have left it off, but I've decided to make it in 2 halves so I can put it together. It makes it easier to turn when you do it that way. So I am going to go ahead and finish the other half and get it ready to glue on here. And then come back and turn through the small hole and turn that inside out. But it's looking pretty good. I make my glue blocks out of nuts, 1-inch nuts that have a 1-inch shaft. And the 1-inch nuts are cheap. You can get them at Tractor Supply for maybe 50 cents, 30 cents. I don't know, they sell them by the pound. But just drill a hole and put them in a block, put some tape behind it, the nuts, so epoxy doesn't get into the threads, and then epoxy it into a block. And now I have another block glued on top of that. And just screw on here. And now I need to surface this thing. And the only thing I'm really worried about, again, is just this outside edge. I don't necessarily need to go anywhere else, just the outside. So this is my top ring. So I'm going to go ahead and center it up and glue that on here. Okay, I'm gonna need the other Longsworth jaws were too big for this. It wouldn't go down small enough. So I'm using a set of Cole's jaws to center it. And I'm just gonna slide it up here and run it around a little bit. Tighten it up on there. And that's it. Let that set a few minutes and then I'll put the next ring on and the next ring on, and start turning this thing out. So about 3 rings, maybe 4 rings, and I'll start turning. I had to go back to the Longsworth chuck, because now it's now I can get it in it, and the other one was too small. So just mark it so I know where my glue line is going to be, and glue this one on. Okay, and again, I'm going to glue this up, but I want to split these seams. So where this joint is, I want this one to be about in the center between those 2 joints. We shove it up here, centered, and tighten it in. Okay, we're going to let that set for a few seconds, and then glue the next ring on. Okay, nobody really ever tells you that you need to clean these slots out, but you do have a little glue squeeze out, and you want to keep that to a minimum. So I come back with a little dental brush here. I forgot what they call it. But anyway, it's just like a pipe cleaner on a stick, and come back and clean those out. Try to get as much of that out as you can. It doesn't look very good when you come back later and have big globs in there. Anyway, just wanted to show you that. Okay, I've got 5 rings glued up on this side and ready to turn it. So let me switch camera angles and get back over here, and so I can turn this thing out. I like to use this tool, an old end tool. It's made out of a steel bar and a 3/16" cutter on the end, high-speed cutter. Easy to sharpen, and it works pretty good for this. It's kind of like a hollowing tool. But anyway, it works great for this. All right, so I have the 2 sides, 2 halves glued together, and now I just need to go ahead and shape it, or rough shape it probably, because I'm not going to shape it all the way. I'm just going to knock these edges off and kind of round it off a little bit, and then hollow the inside out a little more. But then come back and shape the outside again. But that's, it's almost there. Got everything glued together. And now it's just turning it out. Okay, I've got it shaped a little more and ready to turn the inside out. I got to get it thinner, and then the outside can come down some too. But I do have a Lyle Jamieson style, what do you call it, a D hollower or a D handle hollower, and that I made, and it works pretty good. I've got a tip on here at an angle. Oops. I have a tip on here that's at an angle. If you can see that. But so I can get around that corner. I could bend one and make it, but this works fine right now, I think. So let me try it. Hey, it's taking shape here. It looks pretty good. Sanded it a little bit. Still need to work a little bit. He's got some wavy spots in it. And I do need to work on that neck some more before I cut this off. And I have still got it on the chuck at the bottom, still glued to that glue block. The other end up here by the chuck, that's just what do you call that? A wedge joint or something. Anyway, it's where it's wedged on here. I do have a little recess there or a tenon sticking out, so it'll go in the hole to hold it. And then that piece of carpet stuff is, or shelving stuff is keeping it from slipping. But it looks pretty good. I've got the inside all done, sanded out, and as much as I'm going to, and that's about it right there. So let me just keep working on it. I have to keep turning it around because as you can see, my tool rest won't go all the way around this thing. You know, even with the extensions I have on here, I still can't get it around the whole body of it. So I turn half at a time, basically. You know, I want to turn this side, I've got to flip it this way, turn it around so I can reach the other side. So, but like this, I do need to turn this neck down a little bit. So I'm going to do that, work on that a little bit and round it, maybe put a cove in here. And then I'm just about done. If you need to cut it off in a minute, I'll have to flip it around again just to cut it off because again, I can't get a tool rest over here close to it. So we'll flip it around again for that. But let me go ahead and do that and see if I can take a picture of that one. Still got a little swell right here. I'm gonna sand a little more. This ring right here is still just a little high. You can see it, but you can do more by feeling. You know, you can feel that swell right here. But the rest of it will be pretty good. So let me take a little more of that out. The rest of it feels pretty good. Much better. Okay, I think I'm through with the neck. I might go ahead and put a little, no, I think I can sand that out. No, let me go ahead and put a little groove in here anyway. All right, so now it's this end's pretty much done. It's finished. We'll have to sand the top because it's slipping a while ago and it kind of burned it. But I can sand that by hand and should be good to go. Come back and get some of these fuzzy pieces out of here. But otherwise, it looks pretty good. It's nice and smooth and round. I'm going to flip it around so I can cut this off. Let me do that. I've got it turned around and now I can reach this end and I just want to part that off and of course it'll taper so it'll sit flat on the surface. So the rest of this, I've got it sanded down now and kind of about where I want it. So the rest of this, I'm going to go ahead and saw. Coming off. Okay, I have a little bigger grinder. This one here is just a real coarse wheel on a, whatever you call this thing. Anyway. I just want, it doesn't take long with that big grinder, and all I want to do is to get it down where I can sand the rest of it. So let me set that up and show you how to sand it. Yeah, I'm gonna stand it a little bit. Okay, I've got it all sanded down. The only thing left is to sign it and put a finish on it. I left this a little thick, but that's okay. I could go back and hold it with the steady rest and turn this down, but I don't think it looks that bad, so I'm just gonna leave it. Let it go. But otherwise, that's it. I just need to sign it and put a finish on it. All right, it's completed. It's got 366 pieces in it. It's about 12 inches wide and 12 inches tall. The finish is Krylar clear. So it turned out really good, but that was thanks to Mark Soleil. He told me about that instead of lacquer. But anyway, I think it turned out pretty good. That's my video, guys.
That was absolutely wonderful.
Well, thanks. I appreciate that.
That was a good demo and a pretty piece.
Yes, thank you.
Yeah.
I like the detail of you showing step by step what you did. I like that.
Yeah, there's not a whole lot of turning to it. It's just the steps, and you look at it and you say, well, boy, it takes a lot of time, but it really doesn't. I probably did that in a week, but I'm talking a couple hours in the morning, a couple hours in the afternoon, and it's the different steps, so it doesn't get real boring. You only do one step at a time until you get start assembling it, and it goes pretty quick. So, I think everybody ought to try it. The open segments to me is easier, just because you don't have to be so critical with your angle. But, I like both kinds. I just, there's a different jig that I use to actually glue up the open segments with, but
Hey, Bob.
it still works good. Yep, go ahead.
Yes, I'd like to ask a question. From the time that you start figuring out what you're going to be building to the finish.
Albert, somehow you lost your video, your audio.
All right.
Pick up to go again. All right, go
All
ahead,
right.
please.
From the time that you start of your project, how long a period of time does it take to finish some project like that?
Like I said, it was probably about a week. It really,
week?
yeah. It
Steady?
really
Is it steady, or is it just an hour
No.
here, an hour there, or what?
No, I'm usually working maybe 2 or 3 hours in the morning, and of course, I have to have a
okay.
nap. So it's
Okay.
a couple hours in the afternoon, and it might take me 7 days, but
Okay.
time to what 5, so
Yeah.
35 hours or something.
Well, I'm 80 years old and I can't build all those tools. I mean, but I can do it a slower way, I guess. I'm going to try that. Thank you.
Yeah, well, good. I hope you try it. It's really pretty easy once you start going. If you go look at Earl's Small Segment Shop on YouTube, he has lots of videos on doing open segment and closed segment vessels.
Yeah, could you put that on the chat?
Sure.
It's
sure,
in
I'll
the
put it
chat. It's already in the chat.
Okay, thank you.
Hey,
Yeah.
Bob,
Eh,
what told you how wide to cut the splines?
It's the 70% again. You go back to the length of the segment itself, and then I took off 70% of that because I want it to be open segment. So if you look at the distance here between them, between the edges,
Right.
And you measure, whoops, get it up here, where you measure this, or you can see what that 70% is, how much you cut off. So you make it twice the 70%, the portion that you lost, right? And then you have however deep this channel is. And that was probably, 3/8 of an inch deep.
Okay, so all the splines basically are the same length.
Yeah, all the splines are the same length across here.
Okay.
If I had cut, I made a mistake when I did this. I wasn't paying too much attention with the angle of these pieces.
Mm-hmm.
Okay, because if you had done this right, I just got it close. It was supposed to have been 70% of the 10 degrees, right? 7 degrees. Well, it wasn't. When I actually cut these, it was off just a half a degree or something. And when I did that, well, the splines now have to be cut at an angle.
Gotcha.
If I hadn't have done that, if I'd have made these at the right angle to begin with, that spline just could have been a rectangle piece you just slide in there.
Gotcha.
Okay. It's just like when you're making a ring. If you put a piece if it's a closed segment ring and you put a piece in here for a accent, down the side of this, that's just a flat piece, and all you're doing is making the ring bigger. Okay, but it's the same thickness all the way through that spline. Anyway, it is still doable. It's just that I made it more complicated than I had to. I did have to spend more time on each one of these because I had to cut each one of these as a segment, each one of these splines as a segment rather than just having a straight piece there.
Okay. It's gorgeous.
Two things to ask. I was real surprised that you said you only had to wait 3 minutes or 4 minutes when you were gluing pieces up. Dummy that I am, I was waiting at least a half an hour, maybe even 45 minutes between glue ups. You didn't have a problem when you went that quickly?
No, it's the glue that you use. If you use that Thick and Quick, Tight Bonds Thick and Quick,
Okay.
or Quick and Thick, I don't remember what the name of it is, but anyway, it's one of those. When you put it on here and you actually squeeze it together, you can put these rings on, or even the segments. If you're just doing individual segments, you can hold that segment here on it for 5 seconds and go to the next one, 5 seconds, go to the next one, 5 seconds, go to the next one, 5 seconds. And it's good enough to hold it there. And then when you actually want to come back and sand it, yes, you need to wait about 15 minutes after you do this for the ring before you can sand it and, that level, and before you can actually turn it.
Okay.
But the other thing about turning, don't turn. If this is the top ring, let's say you're putting these rings together and you can turn, like this one here. I put those 2 rings on, I put this one on, that one on, and I think I put this one on, but at some point here, I stopped at that level and I turn back down in here.
Okay.
And you just can't turn this top ring that you put on.
The last ring you put on, yeah.
The last one, there's no support here. You've got, too big of a hole. There's no support for those segments.
Okay.
So you can only turn as you go, progression here. You can turn these. And when you get to this one, you glue on another one, you can turn that guy.
Gotcha. The other question, the plans for that tightener, the ring tightener, were on that Earl's website.
Yes, that string clamp.
Yeah.
That's on Earl's website, that Earl Small Segment Shop.
Okay, thank you. Appreciate it.
Yeah, he shows you that. He's got several jigs there that he shows you. You have to look through several of his videos, but and the volume of the videos are usually pretty low, but they are good videos.
Okay, thank you.
Yeah.
Any other notes?
Yeah, one other note. This I don't know if anybody's turned this stuff or not, but every time I work with this bloodwood or even Purple Heart, it splinters. It's real hard wood, but it splinters real easy. And just turning this, just turning it and sanding it down, I bet I got 15 splinters. you know, because they're just like little needles when they come up, when they're sticking up, you know. But other than that, it was fun doing it.
Okay, Bob, if we had an applause sound for this program, you would hear a major applause because this was one fantastic demonstration, sir.
Well, thanks. I appreciate it. Yeah, I hope it was. I hope it was explained well enough where somebody might want to try it again.
Okay, and our webmaster says he'll have this posted in a day or two, and it'll be out there. And folks, all those notes that Bob talked about tonight, including the Type Bond Quick and Thick, is available on Amazon, and Matt Harbour put that link on the chat. That's why we tell you to save the chat, or Donald tells you to save the chat. But this is one beautiful piece of work. Bob, thank you ever so much. It's really great to have a member put something like this together for us.
Okay, I appreciate it. Thanks, guys.